Hi guys. So we are going to go through the Unit 4 retake test, which is really just your practice test. Okay, so here we go. Okay. Similar type problem. We are given moles and we are going to go to moles. So we are given 5 moles of octane and we're going to moles. So this is just a 2-step problem. So I'm going to put 5 moles up here. Okay. And that's of octane. So I know that this one diagonal to it needs to also be about octane. So that's going to be 2 moles, right? Because that's my coefficient. And then we are going to water, right? That's what it's asking about. And so we're going to put 18 on top. Okay. And then I know 18 divided by 2 is 9, and 9 times 5 is 45 moles of water. Okay, so it's not too bad. Let me make sure it's recording. It is. Okay, good. Number 2. So in this case, we have a single and a couple. So we know that this is single replacement or displacement. And then the full balanced equation, we're going to copy the reactants. And then this Ca is going to say, hey, H, get out of the way, because hydrogen is listed first, so it's behaving like a metal. And so then it's going to be Ca with Cl, and hydrogen is going to be by itself. Okay, but before we can balance, we need to crisscross our charges. So I know Ca is +2, I know Cl is -1, so that means I'm going to need 2 Cls. Now it's crisscrossed. And then hydrogen is on my list, but when it's by itself, it has to be with itself. So I'm going to put a little 2. And so now my H and Cl are 2 on this side, but only 1 on this side. So I'm going to put a 2 in front. Okay. Next one, it kind of seems like it's another single displacement, but this is a very special type where you have carbon and hydrogen and oxygen. So we know that this is combustion. And then copy my reactants. And the products of combustion are always the same, which are CO2 and H2O. Okay, combustion are always the hardest to balance. Just do it in a different color so it's a little easier to see. And so normally we would start with our carbons. So we have 4 carbons here and only 1 carbon here. So we're going to put in 4 in front. And then we have 10 hydrogens here and 2 here. So we'll put a 5 in front. But that's going to multiply this oxygen by, 1 times 5 is 5. So that's going to give us an odd number. And that's not going to work. So whenever that happens, just double everything that you've already figured out and go from there. So instead of multiplying this by 4, I'm going to multiply it by 8. Instead of by 5, I'm going to multiply this one by 10. Okay, I couldn't fit that in. So that is still the coefficient. And then instead of 1, this is going to be 2. And then all we have to do is figure out our oxygen. So 8 times 2 is 16, and then 10 times 1 is 10, so that's going to be 26. And then we already have 2 of them, so we just need a 13 in front of this one. So my coefficients are 2, 13, 8, and 10. Okay. Number 4, we have to write the products first, and then we can figure out what's going to be our solid, our precipitate, and go from there. So I'm going to write NaCl, right? My outers are going to go together. And then my inners are going to go together, but I have to list the metal first, which is iron. And then CO3 is a polyatomic ion, so I do keep the subscripts there. Now I need to crisscross my charges. I know Na is +1, Cl is -1, so that one's good to go. So it's a little trickier. Fe has to be 2+ because it was with 2 -1s, and CO3 has to be a -2 because it was with 2 +1s over here. So this is, +2, -2, +1, -1. So they all equal 0, so we actually don't need any subscripts or anything. Now we need to balance. We have 2 chlorines and 2 sodiums, so I'm going to put a 2 here. Now I have to figure out which one is aqueous. Remember our NaNOCA. Okay, so sodium, NO3, potassium, ammonium are always aqueous. So Na is on the list, so that one's going to be aqueous. And then this one has none of them on the list, so that's one's going to be the solid. And so then when I write my net ionic equation, I always start with the end. That, okay, and then I just split it apart. So I have Fe +2 plus CO3, which is -2, and those are, of course, aqueous. Okay. Number 5, in this situation, we're doing our half reactions. So I see that we have this, which has an oxidation number of 0. This has an oxidation number of 0, right, because they're in their elemental form. Na is not going to change, right? It's going to be +1 here and +1 here, so we don't need to worry about Na. Br is going to be -1 here because it's with the +1, and Cl is going to be -1 here. So we can see that the Cl is going from 0 to -1, so it's becoming more negative, which means we added electrons, which is reduction. So I'm going to write Cl2, and we know when we have reduction, we put our electrons on the left, right, the reduction half reaction, and then it's going to go to Cl -1. Okay, we'll get to our coefficients in a second. And then our oxidation half reaction, okay, we're starting with Br minus, okay, and then we know our electrons are going to be on the right, so we're going to be going to Br2, okay, and plus the electron, okay. But we have 2 chlorines here and only 1 chlorine here, so I'm going to put a little 2 in front. You could also have known that because there's a 2 in front of this chlorine here. And then that means we're going to need 2 electrons, and then we'll need 2 Brs and 2 electrons here for the same reasons. Okay. Number 6, we have 2 reactants, AgNO3 and then NiCl, and then you can see that we're going to be going to AgCl. So this is similar to the other practice test, just different numbers. And so we're going to be doing 2 problems going to grams of AgCl. I'm going to set those up. Okay. And for this one, this is my AgNO3 one, and then this one is going to be my NiCl2 one. Okay. Both of these, I'm starting with milliliters. So for my AgNO3, I have 3 milliliters, which is 0.003 liters. Okay. And this one I have 4, so 0.004 liters. Okay. And then I'm going to use my molarity. So this is 0.5 molar. So I'm going to put 0.5 moles per 1 liter. And this one is 1.5 molar. So it'll be 1.5 moles per 1 liter. Okay. And then I'm going to use my coefficient. So Ag to AgCl is 2 to 2. So 2 moles over 2 moles. Okay. And then this one right here, we have a 1 on the bottom, right? Because we're starting with nickel and that's its coefficient. So 1 mole on the bottom. And then we're going to AgCl. So 2 moles on the top. Okay. And then I'm going to be going to my mass of AgCl, okay, which is my molar mass is given to me here as 143.32. And I'm just going to solve. Okay, so let's see here. Get 0.003 times 0.5. We don't really need to do this because that 2 divided by 2 is 1, times 143.32 is going to equal 0.21 grams. And then this second one is 0.004, okay, times 1.5 times 2 times the same thing, 143.32. Okay, and that's going to equal 1.72 grams. Okay, so the reactant that led to the lower amount of product is AgNO3. And then this, of course, is going to be our limiting reactant, or sorry, our theoretical yield. So this one's going to be 0.021 grams of AgCl is all that can be produced. Percent is what was actually produced divided by what should have been produced. So what was actually produced is 0.15. 0.152 grams was actually produced in the experiment divided by 0.21, okay, times 100. So 0.152 divided by 0.21 is going to equal 72%. So multiplied by 100 is going to equal, it's 0.72, but times 100 is 72%. Okay. Last one, there's a whole lot of introduction, but really the most important part is it says lead nitrate is the limiting reactant, and that's this one right here. So this is going to run out, and then the most important part from the equation is that PbI2 is the solid. So we can automatically eliminate A because there is a solid, there is a precipitate. We can also eliminate E because if you see there's PbNO3, and that's not what the precipitate is. So then we're left with these 3 options, and it really just matters what's still going to be in solution. So since this is the limiting reactant, that means we're going to have too much of these 2 things, okay? So that means we're going to have this in solution. We'll have this in solution because they're not going to react. So we should see Na and I in solution. And then also we should see this is also a product, but it's still dissolved. So we should see this and this. So the only one that has NaI and NO3 in it is this one. So the answer is C. It's kind of hard to read, but this is NaI and then NO3. Okay, hopefully that was helpful. End the meeting.